Hi students, so welcome to our channel. I am Dr.K. Varada Rajkumar, Associate Professor, Department of CSE, AIML, MLR Institute of Technology, Hyderabad. In our previous class, we learned about quicksort. In this session, we are going to see midsort algorithm. So, overview of the presentation. So, first we see, so what is midsort? So, after that, we discuss midsort with one example and we see the algorithm for midsort and we see the time complexity, and finally we discuss about advantages and disadvantages of midsort. Outcome of this lecture: at the end of this lecture you are apply midsort algorithm to sort elements in an array. So, what is midsort? So, midsort is a popular sorting algorithm that follows the divide and conquer strategy. So, like quicksort, here also we are going to follow the divide and conquer strategy. The algorithm divides the array into two halves, recursively sort each half and then merges the sorted halves to produce a fully sorted array. So, let us discuss with one example. So, this is the example. Here we have 10 elements. So, 98, 45, 9, 67, 34, 23, 78, 198, 56, 55. So, it is a midsort, it divide and conquer. So, divide the array into two halves. Now, so here we have 10 elements. So this is the representation: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 98, 45, 9, 67, 34, 23, 78, 198, 56, 55. Okay. So, divide and conquer. Divide the array into two halves. So, it divides as 98, 45, 9, 67, 34. So, first half, second half, 23, 78, 198, 56, 55. So, again apply same algorithm. Divide the array into sub arrays. Again, so these 5 elements are divided into 3, 2. So, here it is divided as 98, 45, 9. Again, we divide these elements into 98, 45. Again, these two elements are divided into two individual elements. So, 98, 45. So, these are the 10 elements are divided as 5, 5. Now, again 5 elements are divided into two parts, 3 and another 2 are 67, 34. That is a divide strategy. Again 98, 45, 9 is divided into two halves, 98, 45 and 9. Again 98, 45 is divided into two sub arrays, 98 and 45. Now, this is the base condition. We divide the array into sub arrays until the size of the sub array is 1. So, we stop here and here this is the merge. So, 98, 45. What is the smallest element? 45. So, store 45 here. Now, the remaining elements in second array we append here, 98. Okay. Here we have 9. This is the 9. So, again merge 3 elements, 45, 9, which is small? 9. So, this is the end of the array. So, remaining elements you append here, 45, 98. Again 67, 34, divide into two sub arrays. So, it become as 67 and 34. Now, base condition is the array size is 1. So, now you are going to sort, merge 34, 67. Okay, now 34, 67. You apply merge 5 elements. So, 9 is less than 34. So, 9 here. 45, 34, which is small? 34. 45, 67, which is small? 45. 98, 67, which is small? 67. Now we reach end of the array. So the remaining elements in another array you are going to append, that is 98. Okay, left side is over. So coming to right side. Again, so these 5 elements are divided into 3, 2. So pause the video and try to solve this. So 23, 78, 198. Here 56, 55. Again coming to left side, 23, 78, 198. We divide this as 23, 78. So this is 198. We have only one element, stop here. Divide 23 and 78 into 2 sub arrays. So 23 and 78. Okay. So now compare 23 and 78, merge. So 23 is smaller. So 23, 78. Okay. Now this is already sorted, only one element. Now combine this into 3 elements. 23 is less than 198. Yes. 78 is less than 198. So end of the array. So the remaining elements you are going to append here. So left side is over. Again we have 56, 55. Divide. Now compare, merge 55 and 56. Okay. Now 55, 56. Now again merge 1, 2, 3, 4, 5. So 23 is less than 55. So 23 here. 78, 55. 55 is smaller. 78, 56. 56 is smaller. We reach end of the array here. So the remaining elements 78, 198 is append here. Okay. So this is the 5 numbers at left side. These are the 5 numbers at right side or in sorted order. Now final merge 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Compare 9 with 23. 9 is smaller. 9. 34, 23. 23 is smaller. So 23. 34, 55. 34 is smaller. 45, 55. 45 is smaller. 67, 55. 55 is smaller. 67, 56. 56 is smaller. 67, 78. 67 is smaller. 98, 78. 78 is smaller. 98, 198. 98 is smaller. We reach end of the array here. So the remaining elements in another array append here, that is 198. Now, so this is the input 98, 45, 9, 67, 34, 23, 78, 198, 56, 55, and this is the sorted elements in array, that is 9, 23, 34, 45, 55, 56, 67, 78, 98, 198. In mid sort, we divide the array into 2 halves until the array size become as 1. Now, if there is only one element, that is in sorted. Now, we are going to merge, that is a conquer. Now, here you compare both the elements. Now, place these sorted elements in another array. So, this is the algorithm. So, first step, divide. So, divide the unsorted array into 2 halves. So, conquer means recursively sort each half. Now, so 2 half means 10 is divided into 5. So, 5 is divided into 3, 2. Again 3 is divided into 2, 1. Again 2 is divided into 1, 1. Now, so conquer means recursively sort each half and merge the 2 sorted halves to produce a single sorted array. Here the base case is if the array has one element, it is considered as sorted order. Okay. So coming to time and space complexity, the time complexity of merge sort is big O of log n in all cases. The space complexity of merge sort is big O of n in all cases. Why? In merge sort, we require one extra space to store these values. So the space complexity of merge sort is big O of n. Advantages and disadvantages of merge sort: it is efficient, and another advantage is time complexity. For all the cases, the time complexity is big O of n log n. So disadvantage is space complexity. The merge sort requires extra space to store values. So the space complexity is big O of n here. For bubble sort, selection sort, insertion sort, the space complexity is big of 1, we don't need any temporary arrays. But in mid-sort, we need one temporary variable with the size of n. So, the space complexity for mid-sort is big of n here. So, coming to summary of the session, in this session, we learn about mid-sort algorithm. So, mid-sort algorithm follows divide and conquer strategy. So, divide the unsorted array into two halves. So, conquer means recursively sort each half. So, merge these two sorted halves to produce a single sorted array. Here the base condition is, if the array has one element, it is considered as sorted. I hope you all are understand the mid-sort algorithm. In next class, we see how to implement mid-sort algorithm. If you have any doubts, so place your questions in comment section. I will answer all your questions. Thank you.